So, customer service. Why does this matter? For customer service and resolving negative customer experiences effectively can be an enduring problem for any customer service organization. Resolving customer complaints timely and preventing further escalations and time spent on cases is important for efficiency and productivity. It is important for companies to understand the factors that contribute to furthering already negative customer service situations. The research problem for the project addresses negative customer service complaints and tries to approach the problem from a data perspective. Specifically, what attributes are important when ensuring a first-time resolution to a customer complaint that is not subsequently disputed? And can credit card companies predict when cases may not be resolved after the initial attempt to prevent subsequent escalations? Ultimately, this information is beneficial to understand how to avoid future complaints escalating to multiple touchpoints and streamlining the effort needed to resolve. To drive towards this research question, one key concept from the data was important, and that was if the customer disputed the company's initial attempt at a resolution. So, about the data. The data being used is a publicly available data set posted to the website data.world. The data is a CSV file with 16 columns detailing information about customer service complaints and subsequent escalations. Columns include the date the complaint was received, things like product, which effectively was all credit cards, the issue, which is the transaction that created the complaint, things like balance transfer and billing disputes, the customer complaint narrative, company public response, the company, so Bank of America, American Express, etc., state, zip code, tag, which includes if the customer fell into a special category, including older American or servicemen, consumer consent, submitted via, so email, phone, text, date the complaint was sent, company response. So this is closed without contact or things like closed with monetary compensation, timely response, consumer disputed, yes or no, which is the attribute I will be identifying as the label in the analysis, and then complaint ID. So the data set is quite large with over 86,000 rows. Initially looking at the data, there were a few columns that I thought wouldn't prove valuable in analysis based on the number of missing values and inconsistencies. Consumer complaint narrative was omitted, and you can see here that this was a free-form data field with a wide variation, not easily condensable. It was essentially consumer free-form writing what the complaint was. You can see that it was not overly useful. It was only present in about 15% of the complaints, had a lot of missing values, somewhat entertaining, but that was pretty much it. The company public response, which is not shown here, but that was another field omitted based on inconsistency as well as significant missing values. It was only present in about 10% of the rows. A few other columns were omitted, including the tag, which I think would be interesting for future analysis, but was not populated with any type of frequency to make it useful. And then also consumer consent provided, another rarely populated column. I'm not entirely sure what it meant. When it was populated, the majority of the time it included not applicable as the only data element, so it was omitted. I wanted to maintain the date the complaint was received as an important field in the analysis, but the format in the original file, including month, date, and year, provided way too much granularity in order to draw some meaningful conclusions from. So I added a column for year received and populated it with the year, the year the complaint was received, ended up with 7 values from 2011 to 2017. I loaded the file into RapidMinder to start looking at the entire data set a little more holistically. And when I uploaded the CSV file, zip code and state jumped out as immediate issues in the data with inconsistencies and values that did not make any sense, really. There were a lot of missing values in zip codes and negative numbers, inconsistent characters, 4 numbers, 3 numbers. So it kind of led me to believe that there were a lot of errors in the field. Likewise, state did not have missing values necessarily, but it had over 60 variables, which led me to believe there were a lot of errors, and it was overall not going to be that reliable. So now that I was familiar with the data, it was time to dig into the model. My ultimate goal was to determine any associations between the attributes in the data and the company disputed yes/no value. The data was a little difficult to work with, as most of the items in the columns were polynomial. I switched the consumer disputed, which I had tagged as the label, to binomial and ran a logistic regression to see what types of information came up. Initially, the lowest p-values were clustered around the issue, with items like payoff process or closing, canceling an account. This seemed like it would work, so I added a cross-validation and a performance operator with a tenfold split on the cross-validation. The performance operator showed okay results, with 78.59% accuracy and 78 around precision on the no, not really so great, and the predicted yes column looked a little strange to me. So I went to the cross-validation operator and the logistic operator to update the parameters to try and increase the precision and the accuracy on the model. I upped the folds on the cross-validation to 15 and set the logistic to skip any missing values that I'd missed. The results were pretty much the same though, and the area under the curve is 65.55%, which is really not that great, so I'm not too happy at this point. To get to the research question, I needed to look at the variables that had a lower p-value or p-value closest to 0. The number of variables for some of the attributes, including the issue and the company, created a lot of results with a lot of p-values equal 0 and many close to 0. The variables in the lead, as far as indicating whether the initial customer service response indicated the customer would dispute the initial resolution, included things like other fees, unsolicited issuance of credit card, and late fees. American Express was a leading indicator as well. Along with it, the complaint was submitted by fax. Variables with the highest p-value included most of the other companies, indicating there's something else going on besides what individual companies were doing. So considering that, I took the company out of the data and I omitted that column. So I was trying to hone in on some things that looked like it was achieving some pretty good associations, and since it looked like, other than American Express, the company really didn't matter as far as the significance of the result, I just removed it to make the model run a little bit easier. So the results omitting were a little more useful, as seen on the left, but still with a poor performing area under the curve at 64.26%. The p-values made more sense with issues driving the p-values, including late fee, payoff process, and delinquent account. But I wasn't happy, and I just wanted to make sure that I was not doing something really off track. I turned to the auto model to try and determine what results RapidMinder would produce that I may be misunderstanding or missing in the data. The p-value results were similar, though, with issues driving the p-values, including late fee, identity theft, embezzlement, and payoff process. The overall accuracy is 68.64, but again, the area under the curve performed poorly at 63.6%. So not that much different from what I'd done on my own, and still not great. So I decided to switch gears from logistic and try a decision tree with the same cross-validation to see what types of results were received. The accuracy on just a plain decision tree was still a little disappointing with 78.64%. I replaced it with a gradient boosted to really go all out and see what results were available. The accuracy was really disappointing at 54.88%, but the area under the curve was pretty much holding strong at about 65%. I adjusted the parameters of the boosted tree, including number of trees, depth, and rows, but did not achieve any kind of demonstrably better results. So at this point, I'm ready for some conclusions. Not ultimately very happy, as the results were generally underwhelming. My hope for the data was that I could zero in on a few things that could be translated into real-world items that companies could zone in on from a customer service perspective. But I don't feel like I achieved any sort of accuracy where a recommendation could be made based on the models I used and all of the different parameters I tried. If anything, I would emphasize that the issue is the important factor, not other factors like time period, company, or if the response was timely. So no matter who you are from a company perspective and where your customer is, the important trigger for an unsatisfactory first resolution is the issue, not necessarily any other data elements. I think the data was a bit wonky as well. I wasn't really happy with the amount of adjustments I had to make and the amount of missing variables. I think further development in the course and throughout the certificate program will probably help me really understand what I could have done better with the data. So I'm looking forward to learning that. Future analysis for this data that may be interesting would be just honing in on the issues or looking at those tags, which they weren't populated for very many people, but it would be interesting to see how they drove results.